Okay, exercise 10.01 is about exponential functions. Now, an exponential function is anything in this form where a is a positive number and x is an exponent, right, or an index or a power. You might be curious to have a little play with what happens when a is negative in Desmos. It's a bit crazy. Okay, example 1. Graph y equals 3 to the x and state the domain and range. So we're just going to do this by plotting points. So when x equals -2, negative power, so 1 over 3 squared, which is 9. When x is -1, 3 to the -1 is just 1 over 3. When x is 0, 3 to the 0 is 1. Anything to the power of 0 equals 1. 3 to the power of 1 is just 3. And 3 to the power of 2 equals 9. Okay, let's go ahead and plot those points. So at -2, we're down here at a 9th. At -1, we're here at a 3rd. At 0, we're up at 1. At 1, we're up at 3. And at 2, we're way up here at 9. So we get this shape like this, exponential. You've probably heard of exponential growth before. It's when things grow really quickly, and that's what the curve looks like. So I'm going to find the domain and the range. So one thing you'll find here is that no matter what my power is, as my power goes smaller, I'm just going to get a smaller and smaller fraction. As my power gets bigger, I'm going to get a bigger and bigger number, and that's going to actually grow quickly, really, really quickly grow bigger. That's what's special about exponential growth. It grows really fast. So the domain here, we can put any number in as a power. So the domain is that x is an element of the reals, so it goes from -infinity to infinity. Now the range, we notice that it's always a positive number. It never ever goes below 0, but it goes up to infinity. So y, it doesn't touch 0, so I need a round bracket, and up to positive infinity, that is my range. Now also lastly, is there an asymptote? Yes, there is. The x-axis is an asymptote. It will never cross the x-axis, but it will get closer and closer to the x-axis. We do have some visitors here right now. Hi birds. Nice to have some little birds come to visit. So there is an asymptote. It is the x-axis, which is the curve y equals 0. Okay, example 2 is to graph this one. Y equals 1/4 times 2 to the power of x plus 1. Now, I'll show you how to do this. These are all basically going to have the same general shape, so we can do it pretty quickly and easily. We can start by finding the y-intercept. So if x equals 0, 2 to the power of 0 is 1, it's 1/4 plus 1. Okay, so 1/4 plus 1. Now, 1 is the same as 4 on 4, so 1 on 4 plus 4 on 4 is 5 on 4. Oh, let's just go 1.25. 1 plus 0.25. Now, we just find one other point. So when x equals 3, 2 cubed is 8, 1/4 of 8 is 2 plus 1, so y would equal 3. So the 0.33 is on the curve. So let's graph that. So it's going to pass through 1.25. Let's just say that's about there. So I'll just use each of these as 1. When x equals 3, y also equals 3, so there's another point on the curve. I'll label that. You don't need grid paper for this. Okay, so let's draw a curve through there. Now, I'm also going to just think about what happens. We've talked before about what happens when you plus 1 to the end of a function, and that just shifts it all up by 1. So instead of the asymptote being at 0, the asymptote is now going to be at 1. And we could actually find that by plugging in some really, really tiny little number for x, like -100. And it'd come in like really, really close to 1. So we're never going to cross that asymptote. So it's always good to look at this number to work out where the asymptote is. That will always tell you. So our curve is going to look just like that. So let's call that y equals 1/4, 2 to the x plus 1. So the domain for that, again, x can be any real number, so -infinity to infinity. Our range is from 1, so y goes from 1, it never touches 1, so round bracket, up to infinity. Okay, we'll just do a few more. So graph each of the following and describe the transformation. So we've got y equals negative 3 to the x. Now, first of all, please be aware that this is not the same as negative 3 to the power of x. We can't have a negative as our base for these. So negative 3 to the power of x, remember when you multiply everything by a negative, it has a transformation. It actually reflects everything through the x-axis. So instead of being a curve up here, it's going to be a curve down here. So the x-intercept, when x equals 0, anything to the power of 0 equals 1, but this is negative 1. So just there. And then one other point to give some scale, let's just go x equals 2. So the negative of 3 squared is 9, so negative 9. So let's just put that right down here somewhere and label that as 2 negative 9. And it will look like that. Okay, the next one, 3 to the negative x. Now what you might remember is when we put a negative in front of the x, it flips everything through the y-axis. So let's try it. So if x is 0, again, 3 to the 0 is 1. There it is there. If x is positive 2, we've got 3 to the negative 2, which is 1 on 9. If x was negative 2, we've got 3 to the negative of negative 2, which is 3 squared. So right up here at 9. So we can see this shape happening. And let's label that point as negative 2, 9, just to give some scale, and a 1 there on the axis. I just noticed up here I didn't put the 1 on the axis for that one. That 0 was just for the origin. Okay, and one more. I've got the negative of 3 to the negative x. So it's the negative of this one, which means we're flipping this one through the x-axis. Let's just plot a couple of points. So when x equals 0, we've got the negative of 3 to the 0, so the negative of 1. Okay, let's try negative 2. So the negative of negative 2 is positive 2. So the negative of 3 squared, so negative 9. So we're right down here somewhere. Let's just call that point negative 2, negative 9. And we're going to have that shape. So you can do your graphing pretty basically just like that. Okay, just in terms of describing the transformations, this one is a reflection in the x-axis as mentioned. This one is a reflection in the y-axis. So a negative at the front reflects in the x-axis, a negative on the x reflects in the y-axis. And the last one was a reflection in both axes.